Hello friends, welcome back to our channel. In today's video, we will be looking at the updated forecast of the Bay of Bengal systems and what are the uh, updated expectations of the numerical as well as AI-based models, and what type of weather we can expect over the southern part of India and rest of India in the coming 3-4 days. So let's begin with the current satellite image. So we can see that there are a lot of dense cloud clusters are being seen over the western Pacific and over the Bay of Bengal. So this region from the South Bay of Bengal up to the western Pacific is densely populated with strong convective systems, as we can see in the infrared image that many places of that region is having very intense uh, thunderstorms. Cloud height are reaching approximately 90 kilometer or so. So this is quite strong thunderstorm in terms of the extent in which clouds are reaching into the troposphere. Similar activity is seen over the western Pacific near Philippines, and then we have a continuous band of mild thunderstorms starting from the southern Arabian Sea up to the Bay of Bengal. So it is continuous system without much break in it, and it reflects simply the large scale uh, presence of system like Meridian-Joule oscillations or perhaps the equatorial Rossby waves. Now, if you look at the past 6 hour or so animation of satellite image, it will give us a kind of idea as to how these systems are evolving in time, and is there any circulation pattern which we can identify. So of course there is a circulation pattern over here, as we can, let me mark it for clarity. So we have one circulation pattern here and one very clear, very strong circulation pattern here, and a mild one here, which model are expecting to intensify. We'll discuss later. So we have the three clearly visible from the satellite image, quite a strong rotating system. Now, just if we look at the winds to verify the presence of these systems, so let's look at the models simulations. Let's go around 2 kilometer height, somewhat, maybe let's 1,000 feet height. Yeah, so now we can clearly see the presence of many systems. Let me clear this drawing. Now we can clearly see that there is one very I mean, it's quite decent. In satellite image might not be very clear, but it is quite strong system. Then we have a very strong system here, which is little small compared in size. And then we have one more system which is embedded in the strong monsoon northeasterly winds. So we have a couple of quite interesting dynamics going on, and they are also interacting with each other. As we can clearly note that the winds from one system, so winds from this system are joining the Sumatra system, and they both are connected with this strong jet, and the southern part and northern part of the circulation of these two systems are also joined together. So it is quite a complex dynamical system. And one more system we can see the, I mean, it is in incipient state. It has not developed yet, but it's still present over the Arabian Sea. Now let's see how the WRF model is projecting the system to evolve. So if we just look at for 26th of November forecast, it becomes quite apparent that the Arabian Sea system, the Sri Lankan system likely to intensify significantly over the Sumatra system, and then these both systems are kind of competing to intensify, and the Maldives system is also coming into the picture. He just don't want to left out. He also want to win competition. So these three systems, and another is the Pacific one, which also want to check what is going on in the Bay of Bengal. So it is also joining the party. So let's see how around 28, I mean, all of them are somehow trying to survive. It's quite a complex dynamics. It's surprising to see the Maldives system. It is not leaving behind. It is getting quite strong by 29, and it is by 20 evening of 29. The Sri Lankan system likely to intensify into the tropical cyclone and will likely to merge. The Maldives system likely to merge with it. In meantime, the Sumatra system likely to dissipate. Perhaps it is not forming in the February. It is somehow squeezed by these Pacific cyclone and the Sri Lankan cyclone. So these two cyclones are taking all of the moisture from this poor guy, and now he is just sitting there and struggling to breathe. So it is I'm feeling very bad for this Sumatra cyclone, because see, it is simply squeezed by these two systems. There is nothing left for him, and it is just dying in loneliness. Let's we have little compassion on him. Yeah. So by 30 of, anyways, let's move on to check how it is going to evolve further. By 30th, it will directly landfall over the Pondicherry region as per the ECMWF. And if you look at the rainfall amount, we will see significant amount of rainfall over the whole Tamil Nadu region, and it is extending up to the southern Andhra Pradesh and other region as well. So it is. I mean, the rainfall likely to start from 29 from the southern part of Tamil Nadu, and likely to continue through 30th of November and 1st of December, and it will on and off rainfall will continue up to Tuesday of 2nd of December. So it will likely to be a quite long spell as per the ECMWF model. Okay, now let's what the GFS is expecting. So most of the dynamical features as of today is same compared to the ECMWF model. By 26, it is tomorrow. A similar kind of picture is evolving in ECMWF and GFS model, wherein the Sri Lankan system likely to intensify, and the Pacific system, this Pacific system and the Sri Lankan system likely to take all the resources from this poor Sumatra system, and it likely to weaken, similar to what we have seen in the ECMWF model. And the landfall likely to be around 29th or 30 of morning over the eastern coast of Tamil Nadu, near Pondicherry or or the Chennai region. But the landfall appears to, it is not a proper landfall, it is somehow touch and go type of situation in ECM GFS model, wherein the system is moving very close to the coast and it is not hitting directly the coast, and it will help him to survive for some more time compared to the ECMWF. So it is surviving up to Tuesday, 3rd, 4th. It is continue to exist in the Bay of Bengal, while even 5th, even I mean their signature is even persisting up to 7th and 8th, and then it will again recurve, and I mean what do I say? It will likely to re-landfall over the southern part of India. So it's quite interesting scenario. I don't think that will going to happen, but let's see what Icon has to say. So picture is almost same for up to 3 days up to 27th, but after 27th there is some differences in Icon model. Of course, it is forcing system to move northward, but the Maldives system is intensifying a little bit more compared to the Bay of Bengal, and then it is affecting the track of the Bay of Bengal system. So it is pushing the Bay of Bengal system in the central region, and that is what is causing the whole problem for the Bay of Bengal system to landfall. So this is little different. So it is leaning towards the GFS model. So it is kind of extreme case of GFS model. So the ECMWF is hitting directly to the Tamil Nadu coast. The icon model, the GFS model is also getting this picture, but it is not like directly hitting, but it is just touch and go case. But the icon is extreme case where it is uh, tracking the system up to the central Bay of Bengal rather than the eastern part of Tamil Nadu. So this is a little extreme case of all this. So ECMWF, GFS, and the icon, these are the order. So the ECMWF is very close to coast or almost over the coastal line. Then GFS is very close to coast, but there is no landfall. And the icon there almost there is no significant impact on the southern peninsula India. So these are the three scenario from the three model. Now, which one we can trust? So to further ascertain which model likely to be true, we need to also compensate our understanding from the data-driven model. So let's start with the Pangu weather, which is quite a good model in terms of the track and intensity of systems. So let's check for the southern Asia. Let's wait for it. For let's wait. Loads. Yeah. So now let's see if it. So yes, this is in the Pangu weather. It is likely to hit directly as shown by the ECMW. There is no doubt about it. It is what the this model is expecting. So this is very clear. Without any doubt, this model is clearly suggesting the direct landfall near the Pondicherry coast. Undoubtedly, there is no discrepancy between the ECMWS. So this data-driven model is supporting ECMWF model. Okay. Now let's see what. So one data-driven vote goes to ECMWF model. Now let's see the GFS, the GraphCast model, and let's see which model it supports. And I hope that it will also follow the Pangu weather. Let's see. Yes, let's run it. Let it load further, and it appears to be moving forward. And yeah, it is forming over the Sri Lanka as we have seen in the previous model. Let's see where it is tracking the system. It is also tracking it northwards, and it is also touching the southern part of India, but there is no clear landfall. So it is kind of taking the it is kind of in between the GFS and ECMWF model. So it is not showing any clear landfall. So, but it is not drifting it to central Bay of Bengal. So it is also close to ECMWF model. Now let's see what Aurora has to say. And now let's go to Southern Asia, and then let's look at the 50 hectopascal. Let's see how it goes. Yeah. So it is intensifying the system quite significantly, and the landfall appears to be near, let's see, there is no clear landfall here as well. So yes, there is a difficulty of, I mean, model is finding it difficult to clearly project where it is really heading. So intensification over Sri Lanka is quite evident, but further northward movements remains quite obscure. It is not very clear. So it is dissipating it just after reaching the Pondicherry coast, and it is not showing any clear movement. Now let's see what the ECMWF ensemble has to say. It has been quite promising model for quite some time, and it's consistently predicting good with good accuracy. So the recommendation of this model likely to be quite important. Let's see what it has to say. Let's allow it to load for some time, and then we can have some idea about it. Yeah, it is perhaps landfalling directly over the SimWF ensemble is creating good strong cyclone, and it is kind of landfalling over southern part of Tamil Nadu and Pondicherry. Now, see, central Bay of Bengal scenario is not predicted by any AI model, so we can safely discard the suggestions by Icon and GFS model. Most of these models, data-driven model, are suggesting the landfall very close to Pondicherry coast, and the ECMWF model kind of capturing these kind of subtle dynamics. So I would rather prefer to go with ECMWF model compared to other GFS and Icon. So what we can expect is that the reality will be like ECMWF model. The system will move northwards, and yeah, so it will landfall near Pondicherry coast undoubtedly, and then it will affect the Chennai. So we have to keep an eye on this scenario because this is the most probable scenario and supported by most of the data-driven model. Of course, the intensity might not be very clear in data-driven model because there is interaction with the topography and the land part. Discounting the complex interaction, if we just look at the broad overall picture for the landfall timing and landfall location, it appears that the ECMWF model doing quite well, and it is consistent with the other data-driven model which are independent in terms of physics. So we should be going with the ECMWF model, and it is important for the coastal part of Tamil Nadu to be remain watchful because it might dump a lot of rainfall. Winds might not be that strong, but still 60 to 80 kilometer per hour cannot be ignored. So yeah, let's see how things unfolds, and we will post another update tomorrow after we have more updated forecast. Thank you all for watching, and we'll see you next video. Till then, bye bye and take care.